In this video, we are going to learn about annuity and sinking funds. An annuity is a sequence of equal periodic payments. An ordinary annuity is a payment which are made at the end of each time interval. And if the payments are made at the beginning of each time interval, then it is annuity due. This video considers only the common type, which is the ordinary annuities. That is, the payments are made at the end of each time interval. The amount or future value of an annuity is the sum of all the payments and the interest earned. Let us see an example here. Let's suppose that 1,000 is deposited semi-annually at the end of each 6 months into an account that pays 8% interest compounded semi-annually. 4 deposits are made, one at each interest period over 2 years. So since it is semi-annually, every year you are paying 2, the payment is made on 2 occasions, 2 plus 2, 4, because it is 2 years. How much money will be in the account after the last deposit is made? Now we know that the compound amount will be A equal to P into 1 plus I. So starting from the first deposit, if we are trying to find the rate of interest for the first half, the first 6 months, at the end of first 6 months will be for this interest 8% annually. So since 8% is annually, we have to get the percentage for rate for 6 months. So we have to divide 8 by 2, which is 0.04. So if I'm trying to find for the first 1,000 will be earning an interest for the remaining 3 periods. So 1 plus 0.04 whole cubed, which is 1,124.86. And the second deposit will earn interest only for 2 periods. Third one will earn deposit for 1 period, and the fourth will not earn anything. So we have to add all this. Will give us the sum. So this is the total amount, future amount is 4,246.46. If we are summarizing the whole thing, the sum is the sum of these 4, where the first one is just 1,000, which is R, say. The second one is R times 1 plus I, because it is for only 1 period, and R into 1 plus I, the whole squared, etc. It is just a geometric series. So since it is a geometric series, it will be R into 1 plus I whole raised to n minus 1 divided by 1 plus I minus 1, which is I. So using this geometric series, we get the formula S equal to R 1 plus I whole raised to n minus 1 by I. So instead of using individual values and adding them up, we can simply use this formula. So if we use this formula for R as 1,000, N is equal to 4, and I is 4%, we get the same result as we got in the earlier case, which is 4,246.46. So the formula to find the annuity or the total value, future value, will be R into 1 plus I whole raised to n minus 1 divided by I. R is the amount paid during every period. Now for the future value, the formula is the payment. Instead of R, we treat that as the payment. 1 plus I whole raised to n minus 1. FV is the future value payment, periodic payment. I is the rate, and n is the number of payments. Now remember, we are treating this as an ordinary annuity, which is the payments are made only at the end of each period. So For 2000 is deposited at the end of each year into an account, 9% compounded annually. What is the value at the end of 20 years? And how much of this value is interest? So in the same way, if I use FV, we can calculate the value for the future value as 102,320. Since 20 deposits of 2000 were made, 40,000 was deposited. So this 102, that is the future value minus the amount deposit, total amount deposited, will give us only the interest. The interest will be 62,320. So for this 2000 deposit for 20 years, we get 62,320. When the rate, compounding, and time is known, the ordinary annuity formula can be used to find the future value. So the account that is established for accumulating funds to meet future obligation is called a sinking fund. The payment will be the future value times I by 1 plus I whole raised to n minus 1. Since this is the account that is established for accumulating funds to meet future obligation, that's why this payment, this money, is called the sinking fund. So if you're trying to find the sinking fund for 100,000 with a 6% interest, and when the child is 18, so n is equal to 18 here, so the payment will be 3,235.60. If it is compounded monthly, then the rate I will be 0.058 divided by 12, and the number of years n will be 12 times 15, which is 180. So we get 90,936.69. How much interest is earned? How much interest is earned during the last year? So the 15th year amount will not fetch any interest. So we have to calculate only for 14 years. So this will be that n is not 15 times 12, it will be 14 times 12. So we get this much amount. So part of this growth was due to the 12 payment, 90,936, which is the total of this huge amount, is the remaining growth due to interest. So interest earned for 15 years is this huge amount. The same way we can talk about the growth in IRA. See, suppose if we deposit 2,000 each year into Roth IRA with a 6.85% compounded interest. Now, due to a change in employment, the deposits are stopped after 10 years. The account continues to earn interest until retirement, 25 years after last deposit was made. Now, we are trying to find how much Jane have in the account at retirement. So the first step is to find the future value. The future value will be payment known plus I whole raised to n minus 1 by I, where the payment I, R, everything is known to us. So n is equal to 10. Here I is just R since it is just for 1 year. So it is R 0.06. Now for 10 years, the future value will be this. The balance left in the account to earn the interest at for the next 25 years. So it is P into 1 plus I whole raised to n. So this much amount will be. We can also find the interest rate with the same formula. So you can calculate the value for I from. So the value for I can also be obtained using a graphical calculator. Instead of using quick operation, it is easy to get the value using the graphing calculator. Maybe if we can graph and then find the point of intersection of this and the line 250,000, and that point of intersection will give us the result. So I will be 0.00712223. Since I is treated as x in our graphing calculator, that value of x will be the value for I. You can also use the numerical solver in the graphing calculator. So you get the same answer even if you use the numerical solver method. So you can easily use the graphing method or you can use the solving method. Sometimes tables can also be used, but to complete the computation, we always use a calculator rather than tables, because the main advantage of using a calculator rather than tables is that a calculator can handle many more situations than a table, no matter how large a table is. So it is easy for us to use a graphing calculator TA83 or 84 and get to the point of intersection, or use the solver method and numerical solver method and get the solution. So in this video, we learned about the annuity and the sinking fund. Hope this video was helpful. Thank you for listening and thank you for watching this video.